Imagine a world where life doesn't need a sun. A place where the darkness isn't empty, but full of possibility. We're used to thinking of the sun as essential for life, providing warmth, energy, and the light that powers everything from plants to people. But what if a planet could generate its own heat, deep within its core, through powerful geological forces and radioactive decay? This opens up the possibility of life thriving in the endless darkness of interstellar space, on a rogue planet drifting far from any star, warmed only from within. It's not just science fiction. Planetary science suggests it's possible. Some scientists even believe there could be billions of these rogue planets in our galaxy alone. Traditionally, we search for life in the Goldilocks zone, where a star's warmth allows liquid water to exist on a planet's surface. But a rogue planet, insulated by a thick shell of ice and warmed from within, could hide a vast dark ocean beneath its frozen surface. This hidden ocean, shielded from the harshness of space, could remain stable for billions of years, long enough for life to take hold and evolve. Life wouldn't need sunlight, it would just need a different energy source like the heat and chemicals from hydrothermal vents on the ocean floor. On Earth, life is incredibly resourceful, surviving in the most extreme places, boiling vents, frozen deserts, and deep beneath the ground. A rogue planet might even offer a more stable environment than Earth, no solar flares, fewer cosmic catastrophes, and a steady internal heat source. This stability could actually speed up evolution, letting life focus on developing complexity and diversity instead of just surviving constant change. So, let's explore a hypothetical rogue planet, how its internal heat could power a hidden biosphere, and how life might adapt and evolve in such a unique world. We'll draw parallels with Earth's most extreme life forms, from microbes that thrive in boiling acid to creatures that live in total darkness. The universe could be teeming with life in places we've barely imagined, hidden worlds waiting to be discovered. It's time to challenge our sun-centric view and look for life in the dark, where new forms of existence may be waiting for us to find them. What is a rogue planet? Imagine a world adrift, untethered from the warmth of any sun, drifting endlessly through the vast emptiness of space. It's a cosmic orphan, ejected from its home system, left to wander the galaxy alone, with no star to call its own and no familiar path to follow. Without a star, its surface would be unimaginably cold, blanketed in frozen gases. Temperatures would plunge far below anything we experience on Earth, creating a world that seems utterly inhospitable. But the story doesn't end there. Even in the deepest cold, there can be hidden warmth and possibility. Deep beneath the ice, a planet's hot molten core could keep a layer of water liquid, thanks to geothermal energy that never sees the light of day. This creates a global ocean, sandwiched between rock and ice, a hidden sea that could stretch for thousands of kilometers. The thick ice crust insulates the ocean, trapping heat and shielding it from cosmic hazards like radiation and meteor impacts. In this dark, high-pressure world, the basic ingredients for life, liquid water, energy, and organic molecules, could come together. Just as they do around hydrothermal vents on Earth's ocean floor, the surface may be frozen and lifeless, but below, a hidden ocean could be a cradle for life, teeming with possibilities we can only imagine. Rogue planets, once thought barren, might be secret oases in the cosmic desert, worlds where life could find a way, even in the most unlikely places. The key to life isn't sunlight, it's a protected, energy-rich environment, where warmth and chemistry can spark the beginnings of biology. These worlds challenge our assumptions about where life can begin, forcing us to expand our search for life beyond the familiar. The universe's most unlikely cradles may be its most promising, reminding us that life, in all its forms, can thrive in the most unexpected corners of the cosmos. Water alone isn't enough for life. Energy is essential. Without a constant source of energy, even the most promising environments would remain barren and lifeless. On Earth, the sun powers life, fueling everything from the smallest plants to the largest animals. Sunlight drives photosynthesis, creating the foundation for nearly every ecosystem we know. But in a rogue planet's ocean, there's no sunlight. The surface is shrouded in perpetual darkness, with no day or night, only endless shadow. Instead, geothermal energy from the planet's core creates a dynamic, energy-rich environment. Deep beneath the surface, the planet's internal heat seeps upward, shaping the landscape and fueling powerful geological processes. Picture the ocean floor, geologically active, with hydrothermal vents spewing hot, mineral-rich water. These vents create dramatic plumes that rise through the cold, dark sea, These vents are chemical oases, where life can thrive without sunlight. Here, unique organisms cluster around the warmth, forming vibrant communities in the darkness. Chemosynthetic microbes use chemical energy from compounds like hydrogen sulfide to create food. They form the foundation of a food web that's entirely independent of the sun. This forms the base of a unique ecosystem independent of the sun. Larger creatures, from tube worms to strange crustaceans, depend on these microbes for survival. On a rogue planet, hydrothermal vents would be the suns of the deep, powering entire food webs. Their glow would be the only beacon in the endless night. The beauty of geothermal energy is its stability. It can last billions of years, outliving most stars. This enduring heat provides a reliable foundation for life to persist. This steady energy supply gives life time to emerge and evolve. Over eons, new forms and adaptations can arise, shaped by the unique challenges of this world. No catastrophic solar events, no sudden extinctions, just a slow, steady furnace. Life here is sheltered from the violent outbursts of stars and cosmic impacts. Life here could evolve in peace, uninterrupted by cosmic chaos. Generations could pass in relative stability, allowing complexity to flourish. The planet's internal heat is a dependable engine for evolution, driving change and diversity in ways we're only beginning to imagine. In the darkness, life finds a new way to thrive. Adaptation and innovation become the keys to survival in this hidden world. The deep ocean becomes a world unto itself, powered from within, a testament to the resilience and creativity of life, even in the most unlikely places. We don't have to imagine. Earth's deep oceans show us what's possible. In 1977, scientists found thriving ecosystems around hydrothermal vents, far from sunlight. Giant tube worms, strange crabs, and bacteria flourished in total darkness, powered by chemical energy. These extremophiles are masters of survival, adapted to crushing pressure and toxic chemicals. Tube worms host chemosynthetic bacteria, forming a symbiotic relationship. This proved that sunlight isn't required for complex ecosystems. The chemistry for life is fundamental. Wherever water, chemicals, and energy meet, life can arise. If life thrives in Earth's deep sea, why not in a rogue planet's ocean? Extremophiles evolve rapidly, adapting to dynamic vent environments. A stable, energy-rich world could promote even faster evolution and diversification. Earth's deep secrets give us a blueprint and hope for life elsewhere. The lessons from our oceans point to a universe full of possibilities. Life needs more than water and energy. It needs organic building blocks. On Earth, these formed through atmospheric chemistry and delivery by comets. But on a rogue planet, hydrothermal vents act as natural chemical reactors. Heat, pressure, and minerals create perfect conditions for complex molecules to form. Lab experiments show amino acids and other organics can arise spontaneously in these settings. Unlike Earth's random delivery, vent chemistry is continuous and reliable. The ocean becomes a rich organic soup, a perfect setting for life's origin. Elements like carbon, hydrogen, and nitrogen are constantly supplied by the planet's geology. The setup is almost purpose-built for life, water, energy, and organics, all in one place. In the abyss, the spark of creation is always ready. Earth's history is full of setbacks, ice ages, extinctions, cosmic impacts. Each catastrophe resets evolution, forcing life to start over. But a rogue planet's subsurface ocean is shielded from these disruptions. No seasons, no day-night cycles, no climate chaos, just steady geothermal warmth. This stability lets evolution proceed without interruption. Species can follow unbroken paths, accumulating complexity over millions of years. Natural selection operates in a predictable world, accelerating progress. It's like building a tower without ever having it knocked down. Life invests in complexity, not survival. The result, an evolutionary fast track to diversity and sophistication. Darkness isn't a limitation, it's protection. Life near stars faces constant radiation, driving mutations and forcing adaptation. Rogue planets, sealed under thick ice, are shielded from cosmic rays and stellar flares. Mutation rates are lower and more predictable, allowing evolution to be more efficient. Adaptations aren't constantly undone by random radiation damage. It's like writing in a quiet library instead of a noisy concert. Progress is focused and coherent. Rogue planets are also safe from supernovae and other stellar disasters. Their isolation is their greatest defense. In the cosmic dark, life can evolve in peace for billions of years. The darkness is a shield, not a prison. Sometimes being alone is the safest way to survive. Are rogue planets rare? Far from it. The Milky Way could be filled with billions, even trillions of these wandering worlds. For every star there may be dozens or hundreds of rogue planets. They're hard to spot, but techniques like gravitational microlensing reveal their presence. As technology improves, we're finding more of these cosmic nomads. Rogue planets could represent a huge fraction of all planets in the galaxy. This means the potential habitats for life are far greater than we imagined. Life could arise in countless hidden oceans, scattered across the galaxy. Even panspermia, life hopping between worlds, could happen on a galactic scale. The universe's real estate for life is vast, dark, and waiting to be explored. Our journey to the heart of a rogue planet reveals a profound truth. The universe may be far more hospitable to life than we ever thought. Life doesn't need sunlight or blue skies, just energy and the right chemistry. A stable, protected world could let life evolve rapidly, reaching complexity faster than on Earth. Imagine alien ecosystems, creatures adapted to darkness, communicating with bioluminescence or sonar. Their senses would be tuned to chemical gradients, not light. These worlds could be as rich and diverse as any on Earth, powered by inner fire. Rogue planets may be the galaxy's most common habitats for life. The universe is stranger than we can imagine, and life always finds a way. In the cosmic dark, the story of life is just beginning.